Assalamualaikum and a very good day to Dr. Bakri. Today we are going to present about the design of solar system of buck boost converter. We are from group 3. So for the introduction, I will let my group mate Ahmad Izzuddin to present about it.
Okay, my name is Ahmad Izzuddin Bezaimi, TF1004. I will present about introduction. Okay, first, solar panel device that produce electricity under sunlight. It is one of the alternative to renewable energy that has been used. Okay, second, solar charge controller is one of the important part in solar panel. It relates voltage and current to prevent the battery bank from overcharging due to solar array voltage. Okay, next we use maximum power point tracking MPPT with 48 volt solar panel array voltage as the controller to have maximum power produced and minimum losses. Next, we use buck boost converter as it need to step up to 400 volt of output. The buck boost converter is a type of DC to DC converter with an output voltage magnitude that is either greater or less than the input voltage magnitude. Okay, next, Backboost Converter offer a more efficient solution with fewer smaller external components. They are able to both step up or step down voltage using minimum number of components. Okay, the last one, the scope we will focus on is in the Backboost Converter is useful for control voltage variation. For extension, we can interface solar power with same system so the output voltage remains constant with the help of buck boost converter. Okay, next I will pass to my friends Naim to present about methodology.
Assalamualaikum. My name is Muhammad Fidaus Naim, TF19003. Today I'm going to present about the methodology. So for the first one, what we did some analyzation and researching for the buck boost circuit throughout the theories and also from the internet. And from there, we planned and constructed the circuit based on the founded material. And then we improved the circuit constructed as seen fit with the task given. And for the next one, testing the new circuit that has been completed. After we tested the new circuit and then we finalize it and use it for the solar panel. For the next slide, I will let Darwish Arifin to explain.
My name is Darush Arifin bin Arifin, ID number TF19002. Okay, I will explain about theory and calculation. And first, the theory is buck and boost converter. Okay, for the buck boost converter, is a type of DC-DC converter that has output voltage magnitude that is neither greater than or less than the input voltage magnitude. It is used to step up the DC voltage similar to a transformer for AC circuit. Okay, this is the buck boost converter has two modes. Okay, first mode is switch on, diode is off. The switch is on and therefore represent a short circuit ideally offering zero resistance to the flow of the current. So when the switch is on, all the current will flow through the switch and the inductor and back to the DC input source. Okay, for the second operation, the inductor stores charge during the time the switch is on and when the solid state switch is on, the polarity of the inductor reverse. So the current flow through the load and through the diode back to the inductor. So the direction of the current through the inductor same. Okay, for the second mode, switch is off and diode is on. This mode, uh, the polarity of the inductor is reversed and the energy stored in the inductor released. And the load resistance helps to maintain the flow of the current in the same direction through the load and also step up the voltage as the inductor is now also acting as source in junction with the input source. Okay, this is the calculation of the buck boost. Okay, for Vs we have 48 volt, Vo we have 400 volt, resistance we have 400, and the ripple is 1.5%. Okay, we use switching frequency as 50 kilohertz, and we calculate the duty cycle, and we will get 0. 0.89. And the third step will we calculate the value of inductor. We find the L mean. We got 12.1 micro, and the real inductor will have 15.1 micro. And the final step will we calculate the capacitor, and we will got 11.87 microfarad. Okay, this is the design of our circuit. Okay, this is the flowchart of MPPT designs, and this is called coding for MPPT. Okay, I will pass to my friend for simulation. Iman.
So my name is Muhammad Idman. My ID number is TF19006. So this is our circuit design for the buck boost. So this is the MPPT controller. This is the coding for the MPPT controller. This is we set up the duty cycle, the limit of voltage we try to control, and the output power we try to control. This is the from the flowchart. We use if else statement to present the MPPT controller. So back to the design circuit, and after the MPPT controller, I have calculated the value from the voltage PV and current IV. I will go past to PWM. So then we will go to the MOSFET. So when we run the simulation, so its voltage and current can be varied. So the MPPT controller will calculate and set up a specific duty cycle in order to get a regulated voltage. So our regulated voltage is 400 volt. So for the buck boost, the voltage will be negative. So we will got nearly the 400 volt. This one we got 390 volt, negative 390 volt. So this is our graph for voltage regulated 400 volt. It will be negative. This is our current. So for the next slide, I will be passed to my friend Izudin to talk about our conclusion. Izudin?
Izudin, Mike.
Okay, in conclusion, as the input of charge controller voltage level is 48 volt, we can step up the voltage to 400 volt the buck boost converter. Using buck boost converter, that we can also use the maximum power point tracking MPPT to control the output voltage to remain 400 volt. After that, we know when the cycle less than 0.5, that's meaning is step down. Besides, when the cycle more than 0.5, that's meaning it's step up and the output voltage must be negative. Lastly, an objective is our design was convert DC to DC by using buck boost. Okay, that's all for us. Thank you.